Well, the next speaker is, let me deal with the first topic. The next topic is flood inundation and mapping alert network. We have Kurt, I was going to forget your name.
Golubeski.
He's a water resources engineer with the North Carolina Floodplain Management Program.
Thank you, everybody. Again, I'm Kurt Golubeski. I've been with the state of North Carolina for about 5 years. And today I'll present on our flood inundation mapping and alert network. So this actually might be useful for you in any future exercises you have. So check this out. Also, in case you're interested, on Tuesday and Wednesday of next week, we have a hurricane exercise at the EOC. So let's talk about that in case you want to have a field trip. So who is aware of the floodplain mapping program at the state of North Carolina? This is awesome. Okay, keep those hands up for a second. Who is also aware of FIMAN and our flood inundation mapping, which is a whole different site? Okay, so now all of you at the end of this can raise your hands because you will be aware of this. So this is a whole separate site that we have that is not it's not our floodplain mapping of the regulatory 100-year. This is mapping of any flood inundation event at specific areas across the state. So again, just a quick summary is flood inundation in our alert network. We have a bunch of gauges, and I'll talk about those. I'll show you our website, and then I'll show you the GIS components of it as well, and we'll get under the hood. And then towards the end, I'll show you about ground truthing to see, well, hey, we have these maps. How good are they? So we're really here to prevent and protect both life and property. And we use this site during events, especially during Matthew and any smaller events as well. So I'm going to jump right in to our website. Let me just fire this up. Okay, so first of all, you come into our website. You have a video that shows our director, Sprayberry, who's the director of emergency management. He'll give you a nice summary. Now, if you don't want to watch that video again, you can put in your name, your email address, your phone number, and then select your carrier. When you do this, that will allow you to set up alerts for gauges. So when gauges get to a certain level, it will send you an email or a text. And then you can either watch the video again, you can do Find Me, which will zoom into exactly where your router is, or you just click on FIMAN. So let's just go right into FIMAN and check it out and see what we're going to see. So on our site, you have a big map. You also have your views up top. You have a weather pattern that's showing, and then you have your legend on the right. And then down in the bottom, you can click on any gauge to get more information. And then right now, you don't see all the gauges. You only see those that have rain or have an alert. And then those you can change to see all of them. And then you have your various items on the side. I like the Esri topo myself. And so usually I'll bring that up to have in the background. And then if you click on that one, that will show you exactly where you're at again. Then you can zoom in, you can zoom out. But you're looking at rain gauges, you're looking at stream gauges as well. And I'll go into the details on what's going on this map. This is a snapshot of Matthew at the moment. This is what we're looking at. So we have a NextFIM as well up in the top corner. That's basin-wide mapping on the Tar River. And you can look at certain gauges, and you can go by the basin, the gauge type. You can go by a gauge name, type in the Neuse River if you want, or gauges near me as well. So you have all these options to go find these gauges and look at them across the state. You have summary reports as well. So that will just give you a summary of everything that's going on with all the gauges. Or if you click on it, it will give you a summary of only gauges that are like a flood stage and higher as well and give you a report. So those are more disaster sort of reports that we look at, or an emergency manager might look at, or individual who's interested in gauges might look at. You can turn the legends on and off. You can turn that building legend on and off on the side, and then if you want the weather radar, or if there's a hurricane track, which there currently isn't one, so it's not being fed in, then the latest NOAA hurricane track would be on there. So if you're looking at our gauges, so some of the things we have, as I'll go around and show you, different colors. So different colors mean different levels of risk, okay? And different indications of the circles. So you have the outer circle, which is present conditions. You have the halo. That's the next 5 days, what's going to happen from Southeast River Forecast Center. If they have a blue halo, then that means they've had rain in the 24 hours, is what we have there. And the risk rating, really, we have a nice color of from good to worse, really. Purple has become the new red, so to speak. It's now the most severe color we have. We use purple for the worst. And a few of our gauges don't have, many of the gauges don't have risk rating, but you're also looking at a bunch of precip gauges as well. And then we want to let people know, is it going up? Are things getting better? Things are getting worse? How is it trending? So we show you how it's trending. So you see the arrows going up, you see the arrows coming down to give you a sense of what all we have on the site. So there's a quick overview. You guys can dive into the details on the site, but it's really meant to show you a one-stop shop in North Carolina for where flooding is occurring at gauges that either USGS has, we have, or NOAA has on the coast. So now let me zoom into one of the gauges and show you the really cool stuff on mapping. And this is sort of where, you know, GIS, engineering, and IT and web development sort of all come together in a wonderful marriage of data for all of us to view this, because all three of those are equal components to making this site work. So we have, let's find my cursor on this thing. There we go. All right, so we have gauges. Well, you want to know what's going on at the gauge. What's happening in Neuse River, Kenston right now? Is it flooding? Is it not flooding? We know it's purple, so we know things are bad. So we have inundation mapping, and this is what we mean by, rather than floodplain mapping, we call this inundation mapping. And so we have an area at whatever the height of the gauge is at, that's the area that's flooding right now. Now, one thing to note is look where it's cut off. That's as much as we historically have done, about 3 miles upstream, 3 miles downstream. Now we're changing that around. And so on our site, you have these 3 tabs to look at: current, scenario, and forecast. And on current conditions right now, we're just showing what the current stage is and elevation and stage. We have the flow, if it's flow rated from USGS. And then we also have the hydrograph as well. And so on current, again, we can go through all of the information on stage and flow and the hydrograph. We can click on that, and we can have a better look at what is actually occurring in real time, as well as in forecasted as well. So you see on the left side of that, or right side, I guess, as we're facing, is future conditions. So up here, this is the future from here on. This is current and historical back here. And this data is all coming from the Southeast River Forecast Center. So they have, they put out at about 44 gauges across the state, which we have coming into our site. They will show you what's happening in the next 5 days, what they predict will happen in the next 5 days. And then we have elevations for each of the different risk levels that we have. And you can zoom in and zoom out by drawing a window, which is sort of becoming the norm nowadays with mapping, with graphing. So, and then we always show you what the peak stage is. We show you how many buildings are currently impacted and how then the cost. So that's data that we have buried behind the scenes. We have all the footprints of all the buildings in the state, 800 square feet and larger, and then we calculate damages. And alerts. This is where you signed up at the beginning. Now you can get an alert, and you can set up when you want to get an email or a text on when the river hits a certain level or when it comes back down to those thresholds. And you can add a new alert too. So if you have your driveway floods at a certain elevation or stage, put that in there so you can be aware of it, or your property. Scenario tab's cool. That's just playing what if. Let's just flood this for EM managers. Let's just see what happens at this level, and then let's just work our way up. And this is all color-coded with the flood severity level. So again, orange is moderate. Then we have moderate here, and then major here, and this is minor flooding. And then you can just work your way across. Notice this progressively gets larger and larger, and everything on the inundation mapping that we do is every half foot. So we just slice and dice our model and run it on the engineering side every half foot, and then we map it using GIS in our terrain, the inundation area, and then we color code the buildings as well. If you're curious about the future, okay, what's going to happen in the future? Most people are. Well, then we have a future tab as well. And so this is a time scale about for the next 5 days, and then this is a snapshot of what's actually happening in those time frames. So we know that 48 hours from now we're still at moderate flooding. We know in 24 hours we're at major flooding and beyond. And then we get down into monitor and no flooding at all. So you get an idea of you're on the back end of that receding limb of the hydrograph at this point in time. And then again, you can see our limits of the current mapping that we have. Now we're sort of blowing that away and changing all of that on the Tar River at the moment. So that's a library, and that's what we call all of those inundation sort of areas that we have, as you saw as it worked its way up in elevation. Then you saw the responding inundation area, and on top of that you see the buildings and how they're impacted, and they're color-coded by depth. And then if you wanted to click on a building, you could see how deep the water is in that building and how much damage is done in that building as well. So it's all the focus of, you know, how much damage could be done by an event within this area. Here's an example of those alerts. We're sort of beefing this up a bit. This is a beta alert or a 1.0. We're moving already into 2.0. So you just know the gauge and you get an idea of the flooding that's occurring at the gauge. So again, this is for EM or even individuals. Some people said, I want to know whenever my fishing hole, the water actually gets low enough that it's good to go fishing out there, or kayakers need it when they go out. So there's all kinds of, you know, great ideas on how to use it. So one of the things we have is here are the libraries that we have. Each gauge has a library, but look how small typically you've been allowed to map. And so just these small areas in, we have Goldsboro there, is typically mapped. But we wanted to stretch that out and map the entire basin. So this is where GIS came to the rescue, and interpolation between some of the data we have. We developed this whole new product. It's part of what we have to develop for FEMA. It's called a PAC. It's called a Percent Annual Chance Grid. And it's a different way of rasterizing the probability of flooding. So we had developed this separate from this whole project. And then our contractor came through ESP and said, hey, I've got this great idea on how we can use this. We can use this for Feynman. We said, great, let's move forward with that. Let's talk about it. And so they came back and said, hey, your PAC, this is a little 10 by 10 raster. And what it's telling us is every time, it's telling us at 42, the reoccurrence interval at this little 10 by 10 grid is 42 years, which means that based on our modeling, that 10 by 10 raster grid is inundated for the first time during the 42-year event, and then obviously all the events beyond that. So that means that now, you guys can guess what this means we can do. We can now just say, hey, we've got a raster that goes all the way up to the 500-year event. I don't want to see anything above 64. Well, poof. All of a sudden you have something we've never seen before. You have a 63-year floodplain. I mean, how cool is that? You have a 31-year floodplain. Just play with the numbers. So we're used to seeing the 100-year floodplain and the 500-year floodplain on our maps. Now we can map whatever floodplain we want. And the beauty of this is that this takes into account all the hydraulics of the model as well. I mean, this is a reflection of what hydraulically is occurring in the stream during that flow event that is corresponding to a 31-year floodplain. 14-year floodplain, whatever you want. The catch is, obviously, this is assuming it's the same everywhere. And so river and streams and floods, migrate their way down stream. So you can't incorporate this all over the place. And so, again, we said, well, hey, what happens when there's a 22-year flood in Goldsboro, there's a 14 flood up here, up towards Smithfield, and then down in Kenston, there's a 72-year event. How in the world are we going to map that? And this is almost exactly what was happening during Matthew as well. You just have your peak here, it's coming in, and it's already left up in the headwater areas. So, again, we're constrained, and what we ended up doing is, let me blow through this one because this is the fun one. We ended up taking our modeling, and at every cross-section, we did essentially elevation to reoccurrence interval rating curves. So based on the modeling that we have, we know when the 10 and the 25 and the 50-year and the 100-year and the 500-year event occur. Well, it's just like you do for a rating curve in RAS, where you just want to find out what your stage and flow is. Now we're doing stage and return interval. And so if we apply that to every cross-section, we put that away and store it and pre-calc it, then whenever an event occurs, we can now just assign that and interpolate it from cross-section, from gauge to gauge. And so what that means is that we now have, this was the gauge, little area that we could have in Rocky Mount. Now we can do an entire area and map it with taking what a reoccurrence interval is happening here, and then we just interpolate it up to this next gauge and then all the way farther up. And we're taking drainage area, and we sort of need to normalize it in some way. And so we're saying we are adjusting and weighting that reoccurrence interval at the gauge and interpolating based on drainage area and weighting it based on drainage area. So as a new trib comes in, that means the lower gauge gets more weight to what's happening at the lower gauge than what's happening at a gauge farther upstream. And so in the Tar River is where we've done it. So you can go to our site, You can have a look at the Tar River, and what that now means is, poof, we suddenly have an entire basin of the Tar, and we have or main stem of the Tar, and we have 2 tribs as well, which is just fantastic because we go from having probably about 20 to 25 miles of libraries where you can actually map what's occurring and forecast to occur. Now we go to 350 miles just like that. So we're really excited about this, and we're looking forward to continuing to expand this into other basins as well. And so now, before we had a little snippet in Tarboro, we had this little snippet up here in Rocky Mount. Now we can map the whole area thanks to our engineering, our GIS, and now we can display it using our web developers. It has helped us out. And again, anywhere you want, you can zoom in. You can check out a building that you're interested. Say you live here. This is what's forecast to happen. You'd like to see when it's going to happen, and you'd like to see how high it's going to be. That building there is going to be roughly 1.1 feet of depth of water in that building, because we've shot the FFEs of every building in the 100-year floodplain, and we have that. And we've put FFEs on buildings outside of the 100-year floodplain, but we've approximated those based on the LiDAR that we have. So there's our building. Go down and have a look, and you can see where the flooding's occurring. And if you even get curious for like county emergency managers, they might wonder what's going on with the within the whole basin, or us, the state EOC, want to know how much damage is going to happen to Tar River during Matthew. This will roll it all up by buildings, by depth, and then by cost as well. So our backbone, here's the good stuff. So how do we collect all this data and put it in this website? And how's GIS used at that? Well, we have gauges. We have gauges that we own, and then so does USGS as well. They also have gauges, and we can use their gauges, and we have NOAA on the coast, and we collect our data. This is one of our gauges up in the mountains. Ours are pretty low key. We have a box with our data logger. We've got our precip gauge, and we've got a radio transmitter on the top. And then we have this good old conduit that goes down to our pressure transducer deep around the thalweg of the stream, but usually not. We don't put it all the way that deep. We're not going for drought at this point in time, at least. Out on the coast, same sort of setup. I just noticed the antenna's a little different. We send all the data on the coast up to the GOES satellite, and then it goes out and gets to USGS and to the Weather Service, and then it comes down, and then we log it at our site as well. So again, one of the things that came up recently over the past 5 years that allowed us to do this is we now have building footprints of the state, which we're really excited about. We have damages that we can calculate on those footprints, and we also have FFEs that we have collected. We also have upgraded our GIS server as well. And we're looking more and more. Python is helping us out. Now for our data, it gets a little crazy, but the data's kind of coming in from all places. But the long and short of it is that we have geodatabases that we've developed for other projects. NC Flood, which is where we put all of our floodplain data. We have Risk, which is where we put all our risk data, which is 13 other possible natural disasters. And then we send it up to USGS, and then we get it on our site. We use a company called, or a service called Contrail, and Contrail is owned by OneRain, and that is what houses all of our data. It all comes into that, and then we grab it, or we call it a rover, that we grab it off of that, and we bring it onto our site in Fiman. From a GIS standpoint, this is all used. We use Net Framework 3.5. We schedule the task to run every 20 minutes. We have a web API that runs, and then we grab all of the Weather Service forecasts as well. So we have a bunch of data coming in that we're pinging and grabbing and bringing into our site. The components are just Contrail, the server. We have our rover that we've run, and then we have our NextVim computational engine that runs as well. And so the architecture is somewhat straightforward, but at the same time, we're now happy that it's all stable. So again, we have Contrail, we have our GIS, we're running on 10.3.1, and then we run our Python scripts as well. We use SQL to do all the reporting, and then we email alerts through our email server and through SMPT. And all of that sort of gets housed in one giant SQL enterprise database. Some of the scripts, because they started building it in Model Builder, and all of a sudden that blew up, and so they moved on to Python, and so everything's being scripted now. Model Builder is out, and we just use all the gauge readings, and it runs through everything to come up with what the raster should be for the basin-wide mapping, and then it comes up with all the damage calculations as well. It runs the basin-wide runs in about 8 minutes, so it cranks through things fast. And the outputs we're looking at are, again, we take that raster, we end up taking that PAC, and essentially once we run it, we just compare that to the terrain, and then we subtract out anything that is less than 0. So we're looking at that PAC, and we're looking for anything that is less than the value that we've assigned it, essentially. So I actually should rephrase that. We developed, instead of when you map in floodplain, you map a water surface elevation, we're actually mapping, using the cross sections, a reoccurrence interval surface. And then we take that, so it might be like 15 or 20 at a gauge. We take that PAC that's 20 through 500, and anything that's greater than 20 we wipe out and get rid of. And so you're doing a raster subtraction just like you would for mapping. You would do that with a water surface elevation and a terrain and get rid of everything less than 0. So that's what we're up to. Again, that was our model that we realized that probably should get away from this and move on to Python scripting. This was getting a little out of control. And so here's some example text of what we had in our scripting that's buried deep within the code to run through and calculate our results. So some of the things for us that we've done that's a little different, we do have our charts that are custom charts, and we have a reporting as well, so we can generate reports in PDF form that we can then send to emergency managers. Each of the sites has a photo carousel that you can take a photo, you can upload a photo, and then you can view it on that dashboard at the bottom as well. I just didn't show you guys that part of it, but there's the ability to see photographs. And then for us, for going in and doing administrator tools on it, we can go in and change all the data for each of the gauges that we need to, when moderate flooding hits, what the datum is, what the name of it is, and add photos. And we can turn them off and turn them on, sort of deactivate them, because sometimes gauges don't behave properly and they start to show erratic readings, and so then we have to go in and turn them off and fix that. So the question always is, this is the best part, is ground truth. How good are these maps? We've been doing this for about 12 or 13 years, but we haven't had a chance to get out there and do ground truthing. We just recently took on surveyors as part of the geodetic survey, are now under risk management. And so having them is fantastic, because during an event out in Windsor over on September 22nd, these folks flooded in October and September, and they flooded again during Matthew, 2 roughly 100-year events within 30 days of each other. We were looking at what was happening there. We mapped it, and then we found some photos. Twitter, somebody tweeted out some photos of it, and we just sort of went into social media and saw what photos can we grab to look at what's going on. We ended up surveying as well. But I mean, right here, we're looking right here, and this is essentially right where this arrow is. So, and our gauge is probably about a mile downstream. So we're projecting pretty well what's happening upstream and downstream of this gauge, and we'll have a whole bunch more points. Then we sent out the surveyors. We said, okay, if you guys can get out there to Windsor, please do. Take some points, see how we did. Go out there and shoot right where the water line is, please. And then let's have a look and see what our mapping is at that same exact elevation at that time was happening at the gauge, which is right here. So in Windsor, our gauge is here, and zooming in, this is about as good as it can possibly get. So this is a function of our mapping. It's a function of our terrain. This is the old LiDAR that we collected in 2003 as well, just as a heads up, because we haven't remapped everything on the new LiDAR that we just recently received. So we saw this and we were just blown away. We said, hey, this is awesome. This is great. We didn't get too excited. This is one sample, but this was moving in the right direction. Some other things that we then looked at as well, at the same time we just looked at what was happening for flooding. Well, this building's wet. It's inundated there, just right around the edges, as it shows here. The backyard's got a little bit. We have a little bit. This house here, it's high and dry. Well, this house here is right about there, and it's high and dry as well. So, we're kind of doing a red face test. If you need to make the operational decisions based on what we're showing, could you rely on this data? That's the question we're asking all the time, because we want to ensure that this is good data that people can look at and that they can trust and use to make decisions. So our sort of response back was yes, they can. One of the things at Kenston as well. So during Matthew, Kenston, on the news flooded, had some flooding, and we looked at what was occurring currently and where is our mapping showing. When you're picking up what's happening, little undulations and low spots, swales in the parking lot, something's going right with your mapping. And the gauge here is about 3 miles upstream, because this is right at the end of that gauge library, which is indicated right here. So that was a great way to finish up and have a look at how our sites are doing. We looked at a few other places as well, and so far the mapping is showing that is indicating during that event at that level that the data is operationally sort of sound to be used in the EOC. So if there are any questions, I guess, Danny?
Is there any questions? And please identify which speaker you want. Yeah, jump in the back.
I have a question about the environment. Did you guys do any survey in the areas where the inundation was interpolated between the gauges?
We did do some.
Let me just make sure, because this is recorded. I think your question was there, well, I'll let you come over here and you need to.
Yeah, sure.
You got your wireless on.
Yeah, so you asked about, did we check out where it was interpolated in the Tar River? There were some areas in Greenville that we had to look at outside of it. And the best we did at that time was we compared it to the 100-year, because it was right around 100-year. Because during the event, the basin-wide mapping worked up to a certain point, and then we had issues with it continuing to run. So we had to turn it off. So we have to go back. We have the survey data. What we'd like to do then is go back and sort of rerun that using the gauge data to create a historical account of the event and then compare it. But the best at the time, we knew that it was hitting in green. It was right around the 100-year, and so we were using the 100-year, and it was incredibly close, which we were happy about. But yeah, we're really curious to look at that in the future.
This gentleman right here.
Sir.
Is there what's on the back end? Is there a mobile hydrologic model, or is this more like lookup tables? Like we have this step at a gauge, and we anticipate it will put this many risk cells.
So your question was, what's on the back end? Is it the hydraulic modeling, and whether it's a lookup table that's been predefined? It's both. I'll say it's both, because all of this is based on, the beauty of this is we're not developing new models at all. We're using all of the models that we use to develop the 100-year floodplain and 500-year floodplain. So all of our regulatory models that we have across the state, we're then using those, and so those just have the normal 5 profiles, right? 10 through 500 year. So we go into those, and now we sort of take that model, save it somewhere else, so then we can start to play around with it. And now we run, what flows do you need every half a foot to generate, to hit the half a foot interval? So if we're, at 10, we need to figure, but the 100-year was at 12. We don't have anything at 10, because the 50-year, say, was at 8. And so we have to figure out, usually just to generate a rating curve to start out with, and then we need to figure out what flow will generate a water surface elevation at the gauge cross section at 10. And so that's the traditional that's the way libraries are developed. And so you end up with all your profiles, about maybe 60 or 70 of them, well, usually about 30, because we have 30 libraries, sometimes 30 levels in your RAS model, and you'll have all the flows just pegged, so you get 10, 10.5, to 11, 11.5. And then we use that to then generate the inundation area and the lookup tables as well.
I want to follow up. Using that method, the coastal areas are notoriously difficult to model floods in.
Yeah.
Because, that elevation change is so minor. Can this handle things like storm surges from the coast, essentially upstream flows?
So you asked about whether this can handle storm surges, and I'm glad you asked that, because I didn't have time to talk about it. So now I do. We're working with NC State, with Casey Dietrich over at NC State in the School of Civil Engineering, within civil engineering, and he is helping us take a surge model that's developed by SARA, which is Coastal Emergency Response Assessment. That is developed by a consortium of universities. And they run, every time there's a new hurricane track, and even daily, they will push that through an AdCirc model, through a coastal model, and they'll generate an inundation area. And so you can go to their site. That's what we used during Matthew to see what was happening. And so every time it takes about an hour after every 6-hour update that they'll rerun it. I say every 12 hours. Because every 6 hours they simply update the location, but they don't adjust the tractor's advisory, so they throw a letter at the end of them. So they're doing the mapping. They're mapping that on the terrain that was used for the modeling, so it doesn't always match the actual terrain. We're working with them to take that data, number one, convert it into NAVD88, because that's the only datum that we've ever heard of at the state, until we move to a dynamic one in the future. And then they're going to remap that on our new LiDAR, and then provide that to us. So soon we will display that data on our site, because the goal is we know this is meant to be a one-to-one site for all flooding that's occurring. And that model takes into account some rainfall runoff from the streams as well, tar and Neuse. So it goes up to elevation 40 is as far as their model runs. So that's going to be amazing, because then we can develop live and forecasted impacts on the coast as well due to surge. We won't pick up waves. They do have wave heights, but we're kind of a little shy for picking up waves. We'll get into that down the road. So again, this is meant to be the one-stop shop for all flooding in North Carolina. That's where we're heading to. Yep.
Any more questions? Well, thank you for your attention.
Well, I wanted to ask Kurt to see about the temporal component of this. So I know that the National Hydrological Data Center is they're working on a temporal component on a national scale, where they can take all the rainfall data into account and have that mapped among all the
Are you referring to the National Water Model? Okay, yes, that is. We're in touch with the folks both at Weather Service and then Maidmont as well, who is sort of working on a project called NIFI, which is a way of it's at the water center down in Alabama. So what the National Water Model is that, and it's running now. It's doing rainfall runoff using all of the weather and rainfall modeling, and it's generating flows across the entire state, or entire country, and displaying that in real time, and it's forecasted as well. So that's sort of the beginning stages, and we needed the state to confirm that we're operationally sort of validate it, so to speak, on a state level, that we feel that we can use it to make decisions and to map. But we're very much staying in close touch with them, because we would love to. We're very interested in. The question is, what happens on a day when we don't use gauges for data anymore? How do we use gauges? How do they fit in with the modeling, those two, as they start to overlap and maybe supersede and you ground truth with gauges, but what to use day to day? So we sort of ask ourselves, is there a world, how do gauges fit into the future with the advancements in modeling that are available? It's exciting.
Any other questions? Well, thank you for attending. Let's have a hand for our presenters. Thank you.